Hi everyone, welcome to Behind the Biomedical Engineer, where we talk with BME specialists about their experiences in the field of BME and beyond. Today we are here with Professor Zoe Reidinger, a professor in BME here at WPI, who received her PhD from WPI in 2015. Today, Professor Reidinger's main areas of interest lie in biomaterial fabrication and tissue engineering. It's a pleasure to have you here, Professor Reidinger, to learn a little bit more about the basis of your work with BME. First, I'm just going to ask you how you would describe your PhD research and your current areas of interest to yourself as a second-year university student.
Okay. So my PhD research was in vascular tissue engineering. Also, I want to just clarify something for the listeners, which is that if you hear snuffling, that's my large dog snuffling at the microphone. Her name is Lydia, and she's a love bug. But so my area of research as a graduate student was vascular tissue engineering, where I focused on getting cells to make their own extracellular matrix, and then taking those constructs, which were just made by cells and the materials that they had produced, and stacking them together to make blood vessels. So a fully living, completely cell-derived tissue. So think of them as like living Legos. Since I became a professor, I am a teaching professor, so I don't have a research lab. But that doesn't mean that I don't do any research. It means that most of my research focuses on teaching techniques. So my most recent conference presentations and papers have been all on the ways in which we support neurodivergent students in academic situations, in classrooms, as well as the ways in which queer students find identity as engineers.
Okay, awesome, thank you. Moving on, kind of thinking back to when you were a BME student, an undergraduate degree in BME is often well known for its breadth. How do you manage the breadth and specificity of BME, and kind of how did you navigate that when you were starting to specialize during your PhD?
Oh, that's a big question. So I will tell you how I did and did not manage it, and then I will follow that with a little bit of advice maybe. So first, when I was an undergrad, as I think many folks are, I was the student who was always trying to get the highest grade and take all of the classes that I was expected to, and pick the hardest option, right? So in high school, I took all of the AP classes that were available in my high school. And so when I became an undergrad, I tried to do roughly the same thing. So I picked what I thought was the hardest track, and I picked the hardest classes, thinking that they would prepare me for a career as a biomedical engineer. It was in junior year when I said this out loud to my academic advisor, who looked at me and said, "There is no hardest track. What do you mean you picked the hardest one?" And it turns out that I had picked the track that I thought was the most difficult because it was the track that I liked the least. And so it was the one that I found the most difficult and arguably irritating to do. And that completely changed the way that I thought about my degree, because all of a sudden, instead of always picking the most difficult thing to prove that I was smart enough, motivated enough, whatever, I could pick the classes that I thought sounded interesting, and those were all, like, there are no BME classes here that are filler classes or are just there to be easy. In fact, if you find a class easy, it's probably because you are interested in the material, not because it is truly easy. And so that was one of those things that realization hit me in the head like a brick. And I changed my whole schedule. I changed my 4-year plan. I changed all of this. And I became a tissue engineering track student. Because that was the one that I thought was the easiest. And it was because it was the one that I was way more interested in than the other two. And so, like, my advice for students trying to manage that breadth is look around at the classes that you think sound interesting, and especially like if you're having a hard time with like our 2000 level classes, right? Because you really have to do a set amount of those. You have very little wiggle room. Look at the 4000 level classes and think, which ones do you want to be prepared to be able to take? Like, which ones sound interesting? What do you want to learn more about? And not what would set me up for a career, right? Because all of them should set you up for a career. That's why we have them. And so thinking about like what you find interesting and then working your way backwards can be really useful. And also take each learning opportunity as an opportunity to get to understand yourself a little bit better. It's perfectly fine if in your sophomore year, even your junior year, if you don't really know what interests you the most. That's fine. I'm a kind of a person where I find everything interesting, and the more I know about something, the more interested I am in it, which always felt like, oh no, now I'm never going to find the thing that I want to study. And it turns out there isn't a thing. There isn't there's not one right answer. There are many right answers. And so trying to figure out what some of those right answers were versus the things that I didn't actually enjoy.
That's definitely helpful. I wish I heard that my sophomore year. I feel like when I was taking those 2000 level classes, I was like, I kind of like them all.
Yeah.
I don't know which one I want to do, and I don't know. I think that's really helpful, kind of knowing that you can kind of be interested in everything, just like pick what sounds interesting.
Yeah.
And everything will lead to a different career.
Leads to another point that I'd love to make, which is that if you take all of the classes that you think will, quote, set you up for a good career, but you don't like them, what you're actually doing is you are setting yourself up for a career that you don't like. Yes. You are teaching yourself all of the skills in an area that you don't find interesting, versus taking the classes that you find interesting or motivating or pique your curiosity, which are teaching you all of the skills that you need for a job that will do all of those things. And so if you continue down the path of just taking things because you think that it will get you the highest income or the best job, whatever that means, you are preparing yourself for exactly that job. Yeah. Like the one that is in that area of the classes that you're taking. I don't know. That was a realization that came to me so much later than would have been helpful.
That's very true, though. I feel like a lot of people kind of get caught up in like, oh, I should learn how to code, and but like if it's not something that you want to be using in your career, then
I will tell you, I love that these things exist, but I hate MATLAB. I hate MATLAB so hard. I'm so happy that I have never needed to use that particular software for any of my large-scale data analysis stuff, because it frustrates me so hard. And so, like, that is a tidbit of information that is useful and also changes the way that I think about problem solving, because my brain thinks of using that platform and just goes, oh no. Yeah. Right? Yeah. But I'm really happy that it exists because we can do all kinds of really interesting and useful things. I'm just happy that there are other people who are not me who like it. Yeah. Like there was a student just in my office who was talking about how much she loves MATLAB and how she really wants to do an internship that involves MATLAB. That could not possibly be me. And yet I'm very happy that variation exists. Like that's also why we have all of the different things we have.
Yeah, exactly. Someone can do it, but it doesn't always have to be you.
No, it doesn't have to be you. Yeah.
In the more advice sector to students, failure is often really hard to confront as a student and as a professional. Can you share an occasion during which you encountered failure and kind of what you learned from it?
Oh boy, so much. I actually talk about this in 2 of the 3 main classes that I teach, because I think learning how to accept that you maybe made a wrong choice or you didn't succeed at something can be really powerful. And also doing so with grace and good communication and all of that can make the difference between like a good work relationship or a good product or something that could save lives or harm lives. Like that can make all of the difference.
Yeah.
And so I think one of the things that I bring up in when I do this exercise in my class is I show an Excel spreadsheet of all of the experiments it took to do my PhD. Still looking at that list of experiments makes me feel nauseous. Each one of them took roughly 2 weeks, some more, some less. They're tissue engineering projects. So I was growing those blood vessels from scratch, I guess, from just the cells. And then I was doing something with them. And so each time I planned out the experiment, I had an idea of where we were going. Like all of this was structured to hopefully get the best results out of each one of these experiments. And each experiment took a lot of time and energy and money, like a bunch of stuff. So I pull up this spreadsheet that is all of the experiments. I think there are 117 on there. And then on the furthest column on the right is just an indicator on whether that tidbit of information, so what we learned from that experiment, whether that data was published or presented at a conference or used in a grant. And only about 10% or so of the experiments have that indicated on them, which means 90%, well, it still makes me sick to think about it, 90% of all of it resulted in not data that we could use in that context. That doesn't mean that it was useless, though. Like, I think it is useful to know that, one, I've talked to plenty of other colleagues, and they have also agreed, oh, yeah, no, that sounds about right, about 10%. But also, at the time, right, 9 out of 10 of all of your experiments are not useful outside of the context that you're working in is, just so frustrating. And like sometimes it was because I didn't realize that I had made a mistake. Sometimes it was that we didn't realize that the way that the experiment was set up, that the blood vessels were never going to form because we hadn't used the right protein, or like all of these things that no one on earth knew, but also is not groundbreaking enough to write a paper about it, right? Or that we had ordered some plates from the scientific supply company and they had changed the process that they used when tissue culture treating the plates, and these no longer work the same way. There were so many small variables that changed all of these, and so each one of those experiments has their own painstaking story of what happened, and whether what we learned was useful inside the lab but not in a paper or a grant or whatever, or was just like useful in my own mind to learn that maybe next time you should realize that acetone melts plates, right? Like I did a whole experiment, it took forever, and I was following a protocol that had been done on glass slides, and I was using tissue culture plastic, and I was looking at the cell response to this one material that we had used. And so I was fixing the cells, and then I was staining them, and I was looking for a specific protein, and part of the protocol asked for acetone, an acetone wash, which absolutely makes sense on a glass slide. Does not make sense in a tissue culture treated plate. And I didn't realize, like I was not thinking through it all the way. And I put the acetone in there, and acetone fully melts plastic. Like, that's one of the things it's very good at. And I melted a hole through the bottom of the plate and had fully lost all of that data. Those cells were fully mixed in with the plastic. There was nothing I could have done about it. Yeah. I learned that you can't put acetone into a plate. And that was the only thing I took away from that particular experiment. But it was still something important nonetheless.
Yeah. And I'm sure you never put acetone on a...
I absolutely did not. Which was a good thing to learn.
Yeah, so there's always something to learn, big or small. Where do you see the field of BME going within the next 5 to 8 years?
Ooh. I see two different directions, and I don't think that they're necessarily that different from each other, but I think that they will start different. So one is much more personalized medicine, right? Like, we've gotten much better at scanning a patient and then creating what their particular joint or defect or, heart valve or whatever looks like, so that we can then look at that from a surgical or therapeutic or whatever perspective, and then work with that particular patient. We've also been doing this with all kinds of treatments, right? My uncle just went through some cancer treatments that were specifically tailored to his specific tumor, which was amazing. Yeah. He's currently doing rather well. And then I think the other branch is, or at least a direction that I hope we are going, is in the focus and support of people who were generally and traditionally left out of the process. So that is poorer people, women, right? Like, we have all of these different categories of people who have been traditionally left out of medicine, whether that is through access or the lack of research or cultural support or whatever. And I see a lot of those things changing, especially through the area in which I do a lot of my work, which is the ways in which we design medical devices that are truly useful by folks with disabilities. And like, there are so many different things that were not considered when something was made, 60 years ago. And my hope is that we are getting better and better at incorporating those things and making that more of the standard. So incorporating accessibility into all of our day-to-day life, as well as like what we do in the medical field.
Yeah, that would be awesome. And I feel like a lot of that kind of has been integrated into the curriculum here a little bit. Like, a lot of the projects are kind of based around accessibility and low-cost versions of things. Yeah. So, in fact,
next year I'll be teaching a new course called Engineering Design for the Margins, which will focus on people of color and women and queer people and disability, like a lot on disability, and the ways in which we do and do not have the needs of those populations in mind when creating different things.
Oh, awesome.
Yeah, I'm very excited about it. It'll be a 4,000 level class.
Oh, cool. I wish I would still be here. I would take it.
I'm so excited about it.
That's going to be awesome. And if you could give BME students at any level one piece of advice, what would it be? Other than the one that I already gave, which is a freebie, which is follow the things that interest you. The second thing I would say is even before you think you need help with something, reach out. So some of that is
get to know your professor or your TA or whoever, because you'll realize that once that hurdle is cleared, so figuring out where their office is, when their office hours are, how to get there, once that hurdle is cleared, you will realize that you have a lot of small questions that you wouldn't have gone through all of the effort to ask that first question.
Yes.
But it's really useful, and you will absolutely go and talk to them if you already have done that. And so ask the small questions. This will make it way more comfortable to ask the bigger questions. But also, those smaller questions are really useful to have somebody answer them for you. Mm-hmm. Especially if it's something, like, I think a lot of students have a similar mindset to what I did when I was in school, which was just, I don't understand something, so I'll just continue to bang my head against it until I finally figure it out. And I'm not saying that grit is bad, right? Grit is something we should all aspire to. And also, it is really useful to, if you are realizing that you don't understand something, sometimes simply popping your head into the professor's office and asking a question can shave 8 hours off of the time it takes you to do something, because that professor can help you, instead of repeatedly going down the wrong path of thought, they can help you reorient and figure it out. That's just efficient. Mm-hmm. Yes. And so, of course, try and answer the question, do your due diligence, try and understand something. But if you find that you don't really understand something, reach out. That's what we're here for. That's why we have office hours, drop-in hours, whatever you want to call them.
Yeah, I think that's really good advice. I, again, could have used that. I think
Me too.
A lot of freshman year especially, I would just I'll figure it out if I stare at it long enough, and some things just you won't.
Yeah,
you could just
right?
use a little help. Efficiency is key in college, especially.
Yeah, yep. And asking for help, or even just checking in to see if you're on the right path, mm-hmm. is so useful.
Yeah. And my last question is, mm-hmm. what is the least intellectual thing that you do when you're not at work, and how do you kind of get away from it all?
Ooh. There are a couple things. When it is not so frigid outside, mm-hmm. I spend a lot of time in my kayak. I love a very slow kayak trip. My goal is never speed or distance, but is instead to see how many different animals that I can see on the water. So herons and beavers and muskrats and otters and all kinds of stuff. Mm-hmm. And then during the colder months, I'm all for a nice cozy blanket and some hot chocolate. And I really like to make what I have been colloquially calling unhinged art. But art that is not necessarily meant to be pretty. So mm-hmm. right now I'm in the process of adding so many rhinestones. I'm bedazzling a whole deer skeleton. So wow. I have finished 2 vertebrae, which is, oh goodness, not a lot. I have just now started on the skull. Mm-hmm. But the goal is to have that hang like a mobile up mm-hmm. in my office. The deer skeleton was ethically sourced. Mm-hmm. It was found on my sister's land. Yeah. And it was fully decomposed. There was nothing left other than bones. And she found it and was like, Zoe, please take this. And I said, say less. And I put it in a bucket, and I washed it a bunch of times, and I bleached it, and I took it home with me.
That's awesome. That's so awesome. How long do you think it's going to take to finish
Forever. It's going to take so long. But, I mean, that's part of the whole process, right? It's very... I think that there are plenty of people who, crochet with the same type of mindset or whatever. This is very meditative. I watch a lot of... I frequently call it, educational YouTube, but, don't think that, this is a part of my job. I'm mostly just, I love to learn about the deep ocean and, weird spider facts and whatever, right? Like I'm learning stuff that is not necessarily work related and adding rhinestones one by one to a deer skull in my spare time.
I love that. That's so awesome. There could not have been a better answer to that, honestly. Well, thank you so much for your time. I really appreciate you taking the time to talk with me.
Yeah, and thanks for this project. This sounds really interesting.
Of course, and I'm sure a lot of students will get a lot out of your answers that I wish I did at the time. So
yeah, I hope so. This is also why I hold drop-in office hours. My office hours are always open to any students, not just my advisees or the students in my class. That's why I post them on my door, so that students who have just like fun, silly little questions can pop by. Or anybody who wants to pet the dog, even though occasionally she is loud and barks at people when they knock on the door. Yeah.
Thank you so much.